this question, they first start off by asking us to determine the position of the spring at t is equal to 1.5 seconds. So what we would do in that case is we would just plug in 1.5 into the function. So we would have -3 cosine pi, and then in for t, we're going to plug in 1.5, which of course is the same as 3/2. So I'm just going to write it as 3/2 for now, just because that is a little bit easier to figure out what our trig function corresponding would be, and then plus pi fourths. All right, so we do want to be able to do this without a graphing calculator or scientific calculator. So this is 3/2 pi plus pi over 4. And so you could look inside that argument and say, okay, let me get a common denominator. So that common denominator, of course, would be 4. And that would give us -3 cosine, and then 6 pi plus 1 pi would give us 7 pi over 4. So once we get that, then we would look on our unit circle. Remember, you would divide in half here, divide in half, divide in half. So you would get pi over 4, and then this would give us 3 pi over 4, 5 pi over 4, and then 7 pi over 4. So if you look at your 7 pi over 4, your cosine value would be equal to a positive square root of 2 over 2, and then sine would be negative square root of 2 over 2. And we're just trying to find the position of the spring, so we would have -3 and then square root of 2 over 2. Okay? Now, in part B, when they ask us, so our position of the spring would be -3 square root of 2 over 2. Now, in part B, when they ask us for the velocity function, what we would do is we would take our derivative. So notice that the derivative of cosine is a negative. So we would have a negative times a negative, so that would give us a +3 sine of the argument pi t plus pi over 4. And then by our chain rule, we would have to multiply by the derivative of the inside. And the derivative of our pi t would just be pi. And then the derivative of our pi over 4 standalone constant would go to 0. Now, they are asking for a specific value at 1.5, so you would plug in the 3/2 into our velocity function, which again is just the derivative of the position function. And that would give us 3 times sine 3 pi over 2 plus pi over 4 times pi. So we are looking at 3, and then sine now of 7 pi over 4 times pi. So that will give us 3, and then our sine of 7 pi over 4, according to this coordinate, is negative square root of 2 over 2, and then the pi tags along. So that would be our velocity, and if we are interested in the unit, what we would notice for the unit is that time is measured in seconds, and the distance is measured in inches. So when you think about the derivative, and I've kind of run out of room here, so let me scoot this up real quick. So when you think about v of t, that is your derivative of your position function. And your position function's derivative is denoted as ds dt. So if you think about the unit on s, that would be in inches. So that would be inches per, and then the unit on time here is seconds. So this would be an inches per second unit on the velocity.